So happy Tuesday, Algebra 2. So really quick, we want to make sure that you understand how to multiply because things are going to be real difficult. So I want you to take a moment and try 1 and 2 on your own, and then we're going to go over it in a second, but 1 and 2 on your own. All right, so on number 1, remember you're going to multiply the coefficient, which is going to just be 1. And we're going to add the exponents, which is going to be x to the 4th. So this is going to be x to the 4th power. Okay. On 2, remember we're going to multiply those coefficients. So 3 times 1, which is going to give us 3. And then we're going to add the exponents for our variables, which is going to be 7. Okay. You can probably do 3 and 4. So go ahead and take a moment, pause the video, and try it on your own. Okay, so if we're multiplying our coefficients, we're going to get 2 times 5, which is going to give us 10. And then we just have that x to the 3rd. We can't forget about that guy. And then on number 4, we're going to multiply the coefficients, which is going to give us 6. And then we're going to add the exponents, which are going to be x to the 3rd. Now on number 5, it gets a little tricky. So we can only multiply exponents of things that have the same variable. So for instance, we've got 1 times 7 here, which is going to give us 7, and x to the 1st power times x to the 2nd power, which is going to give us x to the 3rd. But we do have this y just chilling out here. There's not another y over here, but we're going to slap them on. It's kind of like if you were multiplying times like a 1 or multiplying by a different variable, but it just kind of carries along with us. On 6, kind of a repeat of what we've been doing. So 3 times negative 3 is going to give us negative 9. And then we're going to add the exponents of the y variable, which is going to be y to the 3rd power. Okay? Hopefully those weren't too terrible. Maybe 5 gave you a little bit of trouble. But you need to be able to do these without even really thinking. All right, on number 1, we're going to multiply a monomial times a polynomial. So we're just kind of continuing what we did yesterday. But we're going to use some more variables, okay? So it's kind of like what we did yesterday, but again, more variables. So first thing we want to do is we're going to multiply 4y squared times y squared. So 4 times 1 is 4. And then y squared times y squared is going to give us y to the 4th power. Over here, we've got 4y squared times 3. So 4 times 3 is 12. And then we have that y squared that goes with it. Remember, we've got to write these in descending exponent order. So don't forget about that, as well as if it has a y squared over here, but it doesn't have it over here, we still carry that y squared with us. All right, so on B looks a little crazy, okay? This is where I kind of suggest you use the distributive property. You can't use the box method, but I personally like the distributive method. So we've got fg times f to the 4th. Okay, so I'm going to add the exponents of the variable that is the same. So we've got f to the 5th power because 1 plus 4 gives us 5. And then we've got that g just chilling. Okay? And we've got fg times 2f to the 3rd, g to the 1st. So we've got 2 times 1, which is going to give us 2. F to the 4th power because 1 plus 3 gives us 4. And g to the 1st times g to the 1st gives us g squared. We've got fg times negative f squared, g squared. So that's going to give us negative 3 because 1 times negative 3 gives us negative 3. And f to the 1st times f to the 2nd is going to give us f to the 3rd. G to the 1st times g to the 2nd is going to give us g to the 3rd. And fg times fg to the 3rd. 1 times 1 gives us 1, but f times f gives us f squared. G to the 1st times g to the 3rd gives us g to the 4th power. Now you're probably sitting there going, okay, well, can I combine like terms? Here's the deal. The term has to be identical in order for you to add it together. For instance, on this f to the 5th power, we've got nothing else that has f to the 5th power, but also has a g to the 1st attached to it. Okay, so there's nothing that we can combine with it. So we've got to leave all of these alone because there's no repeats of the term. All right. So I want you to try A and B on your own. So make sure that you pause the video and try these on your own. They can be a little tricky, so just try to take it slow. And again, you can use color or you can use the box method. So what I mean by the box method is you can actually draw this box out, and you could say, there are 3 terms in here. You could say 3cd squared and 4c squared d and negative 6cd and 14cd squared. So you're going to multiply each of these if that helps you with your setup. If not, you can use the arrows. But again, you're going to pause the video and you're going to try it on your own. All right. So hopefully you got a chance to try it. So we're going to take this first and then multiply it by this first term. So 3 times 4 is going to give us 12. And I'm going to write it down here. 12. And then c to the first times c to the second gives us c to the third. D squared times d is going to give us d to the third power. Okay, so now we're going to move on to the next one. Times negative 6cd. So negative 6 times 3 is going to give us negative 18. C to the first times c to the first is c squared. D to the second power times d is going to give us d to the third power. Then you're going to take it and you're going to multiply it times the last thing. Okay, so we've got 14 times 3, which is going to give us, 14 times 3 is going to give us 42. Okay, 42. C to the first times c to the first is going to give us c squared. D to the second power times d to the second power is going to give us d to the fourth power. Okay, so now's the time that I'm going to check my exponents of my variables. Okay, and they have to be the same. So, for instance, we got c to the third here. Oh, I'm sorry. We got c to the second here, and we got c to the second here. We can't combine these because they're attached to a d to the third and d to the fourth, and those are not the same. Okay? So, since they're not the same, we can't combine them. They got to stay like this. All right? So, make sure that you have tried B if you haven't. So, now we're going to try B. Okay? So, we've got x squared y. We're multiplying it times this first term. So 1 times 6 is 6. And we don't have an x squared times anything. And then we've got y to the first times y to the third. That's going to give us y to the fourth. And now we're going to multiply x squared y times y squared. Well, x squared can't be multiplied by anything. So we've got y to the first times y to the second, which is y to the third. And then we've got x squared y times negative 28. So negative 28 times 1 is negative 28. X squared times itself, essentially. Y times y is going to give us y squared. And for the last bit, 30 times 1 is going to give us 30. X squared y. And again, now we're going to check our variables. Nothing that repeats, so we can't combine anything. So we are going to leave it like this. Generally, a good rule of thumb is to have it in some sort of descending exponent order. So what I mean by that is you've got 4, 3, 2, 1, which is good. You also kind of want to have it in alphabetical order. Okay, alphabetical order, X comes before Y. Okay. So if you're ever like sitting there and you're like, I don't know which comes first, make sure that you write in alphabetical order and descending exponent order. Okay? All right. So at this point, you're probably sitting there and you're like, I'm not doing any more of these. One thing to keep in mind is on these, you're going to see these on your SAT. You're going to see these in pre-calc. You're going to see these again. So you've got to have a good system. This is really more about organization than anything. So when you multiply any two polynomials, use the distributive property. So these are all the arrows and everything. You also know it as FOIL. And multiply each term in the second polynomial by each term in the first polynomial, or in the first parentheses. Okay? So on A is pretty simple, but we're going to do it together. So A times 2 is going to give us 2A. A times negative 5A is going to give us negative 5A squared. A times A squared is going to give us A to the third power. And then we're going to take the second term and we're going to share it So negative 3 times 2 is going to give us negative 6. Negative 3 times negative 5a is going to give us positive 15a. And negative 3 times a squared is going to give us negative 3a squared. Now, this has just become a problem just like what we did yesterday. So we're going to highlight our like terms. So anything that has an a squared, we're going to put it in green. Anything that has just an a, we're going to put it in yellow. And then nothing else repeats. Remember, we've got to write it in descending exponent order. So our biggest exponent is this a to the third power. So we're going to have a to the third power. Then we've got a squared. So we've got negative 5 and negative 3. That gives us negative 8a squared. And then we've got, I should have written that in green, sorry. 2a and 15a, that's going to give us 17a. And then we've got a negative 6 just chilling out here. Okay, so descending exponent order, and we're done. Okay? On B, it's kind of like what we did earlier. So, again, we're going to distribute. We're going to take what's on the outside and multiply it by each individual term. So we've got x squared y times 6y cubed. So 6 times 1 is going to give us 6. There's no x to multiply by. And y to the first times y to the third is going to give us y to the fourth. We're going to take it and we're going to distribute to the next term. Well, there's no x squared, nothing to multiply x by. So we're just going to bring that. And then we've got y to the first times y to the second, which is going to give us y to the third. And then we've got the next term. So 1 times negative 28 is negative 28. There's no x to multiply by. And then you have y to the first times y to the first, which is going to give us y squared. And we're going to multiply by that last term. So we've got x squared y times 30. 1 times 30 is 30, and then you've got x squared y. Okay? A similar thing is going to happen with B, but on this one, you can use the FOIL or you can use the distributive. I'm going to show you how to do it with the box. It's a little messy if you're not an organized person, but I'll show you that way. So we have 3 terms in the first one, and then we have 3 terms in the second one. So you should have essentially 9 boxes. Okay, so you've got y squared times y squared, which gives you y to the fourth. Negative y times y squared is going to give you negative y cubed. Negative 3 times y squared is negative 3y squared. In the next column over, we've got y squared times negative 7y, which is going to give you negative 7y to the third. Negative y times negative 7y is going to give you positive 7y squared. Negative 7y times negative 3 is going to give you positive 21y. And then you're going to do y squared times 5y squared. Negative 5 times negative y times 5 is going to give you negative 5y. Negative 3 times 5 is negative 15. So now I'm going to highlight all of the terms that have the same variables, the exact same variables. So we've got negative 3y and negative 7y cubed. And then we got 7y squared, 5y squared, and negative 3y squared. And then we've got 21y and negative 5y. So we're going to combine. So we've got y to the fourth, which is our top thing. And then we've got negative 1y cubed plus negative 7y cubed, which is going to give us negative 8y cubed. And then we've got everything that's in the blue. So we're going to add all of that together. So negative 3 plus 7, which is going to give us positive 4. 4 plus 5 is 9y squared. We got 21y and negative 5y, so that's going to give us 16y. And then we've got this negative 15 just chilling out here. Again, descending exponent order. So go ahead and take a moment, pause the video, or this video is actually going to run out. So try these on your own, and then you're going to check your work. Okay,